introduce yourself?
Yeah, sure, absolutely.
Let's introduce about what Shelby is.
Yeah, absolutely. So I head the infrastructure teams at Aptos Labs. I've been with Aptos Labs pretty much since the beginning. And now my focus is completely on Shelby. I lead all things Shelby. Before Aptos, I was at Meta, where I build Meta's core infrastructure, core compute infrastructure. So myself and some other engineers at Aptos, we are part of building out the core infrastructure of Meta, where all of the Facebook, Instagram, WhatsApp, all of the data was being processed in one place. And we are processing more than an exabyte of data every day.
What problem is the Shelby designed to solve for the sort of the next generation of Web3 builders?
Yeah, and I'll kind of step back and talk about where we are as an industry and where we are going, right? Okay. So as an industry, we have talked about the potential of decentralized technology, and it's now time to convert that potential into actual on-chain revenue, right? So when you think about revenue, look at any big tech company. Where does the revenue come from? Revenue comes from data and algorithm, right? You have your data, you have your algorithm, but all of your data is now being kind of siloed into this big tech data centers, and we want to free up the data. We want to decentralize the data ownership. So the ownership comes back to you. But when you look at the decentralized data storage landscape, what we have right now is cold storage, which is when you take the machines and left of spare capacity, like I have a big machine in my garage, I want to just store some data there. That will allow you to store data, but you will not be able to access it fast enough so that you can build a live data-based, data-driven applications like streaming, like data processing engines. You cannot build anything like that. So when Jump Crypto and Aptos brainstormed kind of the state of the infrastructure right now, we both landed on the same conclusion that the hot storage tier, where data can move really fast across the network, you can serve tens of gigabytes per second throughput at a sub-second latency. That would unlock the value that all the big tech is kind of deriving from data right now. So that is where Shelby is the missing layer, the missing data layer, which has all the value. So we are building the hot storage for the decentralized infrastructure.
Talking about middle, so in your presentation, you said something that caught everyone's attention. So the value is in the middle.
Value is in the middle, that is correct.
So you compare the data stack to the sandwich. Cold storage at the bottom and cache at the top.
Yes.
But the hot and large middle layer is missing.
Yes.
So can you unpack that a bit?
Absolutely, I would love to.
Why is that middle layer so hard to build, and how does Shelby finally make it possible?
Yeah, I would love to. Let's talk about the first two layers that exist, the bread layer, so to speak, right? So the bottom layer is the cold storage, where you can archive your data, you can store your data. But any cold storage systems that exist right now in a decentralized, I'm talking about the decentralized infrastructure, when you try to read data from it, it takes few seconds. You're not going to build an application where you say, oh, I'm loading the video, but wait few seconds, and then you load a few seconds and now wait few more seconds, the other video is loading, right? So there's a very simple example, but and then you talk about the cache. From cache you can now serve the data fast, but you can easily empty out the cache because you have one machine that is kind of serving some data. When you think about where is the value is in processing the data and serving the data at scale. Think about YouTube, think about Netflix, think about Google and all the search indexes that they build. Think about the model inference and training that OpenAI does. It's all data driven, but it's all about hot, fast data. And it is very hard to build because you have to first store petabytes of data and be able to move all of that data across the network seamlessly at tens or even hundreds of gigabytes per second. That takes extreme high performance engineering, that takes very deep infra understanding, that needs teams who have built that kind of infrastructure before. And in Aptos Labs and Jump Crypto, we have found the collaboration that teams have that expertise. So we said, okay, let's build something that nobody is able to build but has a lot of value. So that is the layer in the middle that we are building. And we are the entire thing is completely coordinated on blockchain. So I was bringing that blockchain experience, Jump Crypto brings their high frequency trading experience, and together we are building to unlock the value.
Yeah, I think we need another interview just for this.
Absolutely, okay. I can talk for hours if you want.
So you also describe data as a thermal and temporal.
Yes.
So some really fresh language there.
Yes.
That's a beautiful phrase. That data gets hot or cold over time, and it needs to be more fluid through these states. So how does Shelby Shelby handle that sort of dynamic data lifecycle?
Yes, yes.
Is it fair to say that you're building the first decentralized system that actually understands sort of time and context in the data?
Yes, yes. So I think let's unpack data being temporal.
Okay.
Right. So it's a time-based. The fresh data, as something is happening, as you know, like data is almost real time, and the demand for real-time data is extremely high. We all know that.
Yeah.
Like this interview would be viewed many times in next week, then less times in the week after, less times week after, right? And so the data has like this time element to it, but then it's thermal in the sense that suddenly content can go viral, and now the data that was like sitting in some cold tier now needs to be served to millions of users, right? So suddenly it becomes hot.
Yeah.
Then over time it becomes cold. And you do not want to put the burden on the data generator or the user to say, oh, if you want to now serve it, you have to move out of this system, put it in that system. Now you have to think about different billing system. You have to think about different kind of management, different security. So Shelby as a V1 is building the most difficult part, which is the middle part.
Yeah.
And the one reason that the value is in the middle is the middle part can seamlessly now move data as it gets colder. It moves to a more cost efficient structure, and it becomes hotter, it moves to a more server friendly structure, right? So data can, as it becomes hot or cold, the thermal part dimension can seamlessly move, and the temporal dimension also can seamlessly move. So again, Shelby is going to enable both of that, but V1 we are focused on the hot and large, the middle tier, but then V2 will have the full thermal and temporal dimensions.
Oh, it's so great, and I feel like I'm listening to another lesson at university. But it's amazing that this is happening on chain, on blockchain.
Yes.
You know, what you don't normally see in a Web 2, for instance. So from what we understand, Shelby isn't just a decentralized database. It's a performance layer that can power analytics, inferences, and even AI model
Yes.
training.
Yep.
Can you walk us through its core architecture?
Yeah, absolutely.
What makes Shelby fast, cheap, decentralized, and how does it compare to a sort of existing cloud or distributed systems out there?
Yeah, there's a lot to unpack.
Yeah.
So let's go on your first question,
Sure.
like what makes Shelby fast and how we build Shelby. So there are 6 architecture pillars that we talk about. So first and foremost, any decentralized system, your incentives matter a lot, right? So you have to make sure that your incentives are aligned with the goals of the system. So Shelby has put incentives for the storage providers to serve out data as fast as possible. So we are incentivizing reads, right? And one of my favorite quote here is like what Charlie Munger said, that show me the incentives and I'll show you the outcome. So now if you are paying the node providers to say, serve out your data as fast as possible, otherwise somebody else will.
Yeah.
So now all the nodes now compete to serve data as fast as possible.
Sure.
So that's one incentives aspect. Then there is a network aspect, right? When you have to move petabytes of data across the globe really fast, you need very high bandwidth network. So we are partnering with 00. You saw the presentation today from Austin. So 00 is building this connectivity layer, which is going to that layer will provide about hundreds of gigabits per second network throughput for Shelby, and some of the throughput will be completely dedicated to Shelby. So we are not even going to compete for traffic. So that is number 2. Number 3 is how we lay the data out. So the data layout is extremely important, because you can have a very naive implementation where you say, I am going to take your data and copy it 10 times so that we never lose the data, right? But now you have to pay for the data 10 times, and now your system becomes very expensive. So Shelby has an erasure coding system which takes your data, splits it into 16 chunks, such that even if you lose 6 chunks out of that, you can recreate the data very fast. And it's a known system. That's how big clouds operate. But we have found erasure coding protocol called clay coding that gives us the optimum repair bandwidth. So this is slightly technical. We can go into the details if you want. The 4th pillar is a very fast, high throughput and low gas fee blockchain.
Yes.
And that is where Aptos comes in, right? So we have the highest throughput, lowest latency and lowest gas fee. So that combination now shines, like it's time for Aptos to shine. And so those are like some of the key components that makes entire Shelby protocol really fast and at a very reasonable cost.
And decentralized.
And decentralized, fully decentralized.
Yes. So one of your key points was that AI needs performance.
Yes.
And cost efficiency.
Yes.
You mentioned that the current cloud fees are strangling GPU utilization.
Yes. Yep.
So how does Shelby solve this? And can it realistically outperform traditional cloud systems like AWS, Google Cloud Platform, not just in theory, but in enterprise-grade use cases?
Yep. First of all, thank you very much for listening to my presentation.
I have to write about it.
No. So all the work I put in presentation was worth it. So thank you. I appreciate that. Yeah. So I think this, as we move forward, this particular topic is going to become the most relevant and most important when it comes to Shelby. AI is the biggest, the pace at which AI infrastructure is moving forward. Forget Shelby, forget decentralization. Just AI infrastructure by itself, the way it's moving forward. If you listen to Jensen Huang, he says that even if you remove NVIDIA GPU and even if a competitor sells you GPU at no cost, the NVIDIA system is still going to be more cost efficient for you, even if you get a competitor GPU at no cost. The reason is that what they talk about is that they are building, they call it extreme co-design.
Okay.
So it's not just about GPU, it is about how fast you feed the data into GPU so that your GPU has maximum efficiency, right? And how your multiple GPUs can connect to each other and how the system cohesively works together, right? So for that, they have built highly optimized data caches that can feed the GPU really fast. Now, the challenge is that again, caches cannot hold lots and tons of data. So you have to, what you call, hydrate the caches very fast.
Okay.
Right? So you have to bring data to this kind of farms of GPUs. And by the way, they are called neoclouds now.
Okay.
So there are a bunch of neoclouds, like CoreWeave is a prime example. So when it comes to AI training, inference, and now even with the thinking model, there is also the inference and training, they're blending into each other because it's not a one answer. If you see any model, there is a thinking mode, right? So the model iterates over its own inference multiple times before giving you the right answer.
Now I know why.
So I think that is where the goal for the AI infrastructure is to get maximum tokens for the watt that they are pushing in. And that is where to keep giving it the data is very important. So now we established the goal for AI infrastructure. Now where does Shelby come in? We are talking to some neoclouds and they said the cloud, the data for a lot of the customers is sitting in big cloud like AWS, Google Cloud, etc. They have to pull the data out and put it in this cache. Next day they are training again, pull the data out again, put it in the cache again. The clouds charge you for egress fee, and then egress fees are very extractive. There is a lot of margin built in. There is also, they want to discourage you and they say, hey, use our model training and we'll charge you less. Why are you taking it out? Right? So for many reasons, that cost adds up. And so now I, as a data owner, I say, I don't want to egress too much data from my cloud. I'm going to give only some data to the neocloud. And the goal for the neoclouds is to have maximum GPU utilization. So this is where Shelby can come in because our egress costs are order of not multiple times cheaper than big cloud egress.
Okay.
But we can give you the same performance. So Shelby can hydrate the caches for neoclouds much efficiently.
I see.
That is our step one. But when you think about step two, and us as infra builders, when we worked at Facebook or when Jump Crypto built their own high performance systems, we all know that you have to bring data and compute very close together. So in very near future, we see Shelby nodes being close to a GPU farm and feeding the data so efficiently, so fast, at such a scale that you can think about Shelby itself as a neocloud, a decentralized neocloud that is optimized for AI training and inference.
That's great.
So that's a direction.
That's explanation. Now I know why it says thinking and different modes, for ChatGPT.
Yeah.
So you also emphasize that Shelby brings ownership, IP, provenance, rights management into data workflows. Something sort of I think AI sorely lacks.
Yeah.
So how will this work in practice? So can creators, enterprises like news outlets like us truly own and monetize our data directly through Shelby?
Yes, absolutely.
Rather than handing it over to a sort of black box AI model?
Yeah, absolutely. And I think that's
great news.
Yeah, we all know that New York Times and OpenAI had this lawsuit, right? And
yes.
It is a black box where the data came from, what data was used, and Shelby we have a kind of, we announced our DevNet, and one of the features you'll see, you can just play around right now if you want, is like, I am uploading this data, but when I upload, I want to say, there are a few options that you can select. Who has access? You can say, oh, anybody who makes a payment of this amount will have access. Anybody who's in my allow list that I have already kind of, I have some other contract that is on chain, that has access, or I have my custom programmable logic. I'm going to put some logic. Here is my code. Based on this code, you should provide access to people to my data. So that puts full control in your hand. And then that's if an AI model now wants to train on certain data. And we all know that the models have been trained with openly available data, right? So next round of model training is going to be on proprietary data, specialized data, closed data, owned data, enterprise data, IP protected data, right? And all of these can be enabled by Shelby having this layer of access control, but the data is completely owned by you, and you selectively participate in the model training for the price you want to decide.
That's awesome. That's really awesome. You also mentioned yesterday that when Shelby and Aptos global trading engine come together, sort of they will form a sort of a symbiotic loop. That's what you said. I think it's like a Wall Street or Silicon Valley.
Yeah.
What does that mean practically? Are we seeing the rise of a new sort of economic feedback loop where innovation generates data creates value, and then value flows back to sort of the builders or the programmers? Is that what you're...
That's exactly it.
That's it?
Yeah, you summarize it so well. You summarize it.
Because thinking about it, I was thinking, what does that mean?
Yeah, you summarize it better than I can, but I'll elaborate a bit more. Because, so that's where, like, look, we have been, like our team has, a lot of us come from Meta, right, where Facebook, and we have seen, and as I talked about, the value in the new digital economy, the value is in the data. Starting like, going back to, I think this is not a new trend, like going back to like 98, when Google built the first search index and put PageRank algorithm, right? So got the data, got the algorithm, and that has since then, it's been about data. And then you have seen all these big IPOs. They get listed on Wall Street. The capital markets then react very positively because you have real growth, real users, and even real revenue. So then you get this extremely positive response that allows you to raise capital. That capital gets invested back into your now technical and innovation stack that allows you to build new things that kind of feeds back into that. Now the capital market says, oh wow, I love this new thing you're building. I'm gonna buy more of your stock, right? So that the whole loop that we have seen play out, that should be now played out in the decentralized economy. That we have this D app that is building something, a new creator economy platform, which has prediction markets built in, which has some sort of trading built in, and then their token generation that gets listed on the capital markets, which are powered by blockchain. That T gets, as much excitement as a big IPO. They raise as much capital, so that it's the same loop. Yeah, that's what we are trying to build. But that means that we bring the revenues on chain, right?
Yes.
So we bring the decentralized economy to life.
Yeah. You also teased partnerships in media and entertainment, and I got what it was this morning with NBC Universal.
Right.
And a few others, saying that when data and content payment IP go on-chain, so new revenue streams are born.
Yes, yep.
Can you share more about that? How Shelby will power the next generation of sort of creator-owned media? And AI-generated platforms.
Yeah, and this is kind of overall the premise of not just Shelby, but a smart contract-powered platform, right, that would have your rights, royalty, IP, data, and payments. And let me unpack a little bit, and especially in context of Watchy that we have announced. We have big partners, big studios, and as if anybody has worked in the enterprise space on contracts and terms and conditions, it gets very unwieldy and very complex very fast.
Yes.
Right? And so the management of who has, like we have all watched reruns of Friends on many, many different platforms, right? Time and time again. Now, who has access to Friends season 5 for Southeast Asia, from this duration to that duration? That entire thing is like you have to unpack. And now, if I am a developer who wants to build a new experience and say, I'm building a dating app and I want to get like this Friends episode 6, because it's perfect for like a virtual date. That would be amazing to build that out. I would love to go as a developer, go to a content platform, pick it up for the right price and give it to my users.
Sure.
It's not possible right now
Yeah.
because the whole thing is such a entangled kind of a bowl of spaghetti. Right? If you bring it now all on chain, where now you have clear visibility of who can sell data where, who has the right, and who can buy for what price, you can bring new content experiences to life. Right? So that is the whole goal. So big studios, they can only engage in large deals right now because they have to unpack everything and they have to do the whole work manually.
Yeah.
So that is the whole goal for Watchy as an OS. You'll have everything in one place. So as an enterprise, your workflows get streamlined, and as developers, you have access to high quality produced content at your fingertip, and you can easily integrate in your systems.
That's great. Really, it's a dream come true for guys who create content for life.
Yeah.
Let's zoom out for a moment. When you imagine Shelby in 5 years from now, what does success look like for you? And do you see it as a new sort of decentralized cloud, or a data marketplace, or something even more profound? Maybe the infrastructure for the entirely new digital civilization?
Yeah, so our industry, and when I say our industry, the Web3 industry, suffers from hyperbole, right?
Yes.
Everybody is just, wants to reimagine humanity. And Shelby has very high ambitions. We want to go one step at a time.
Okay.
So I think if you look at 5 years, the success looks like if we have a decentralized cloud where we can put ownership back to the users and developers. We can give them seamless experiences, very high performance at very, very reasonable cost. We can bring new experiences to life, and the whole kind of digital economy, if we can start making a dent into that vision, we'll feel extremely successful, right? And that's a goal. And I really thank you for having me on this conversation. And Korea is our second home for Aptos and Shelby. We want to come visit everybody in person very soon. So I look forward to now having another conversation with you in Korea.